Heat transfer is a key principle in architecture, directly affecting a building's thermal comfort and energy efficiency. It occurs through three primary mechanisms: conduction, convection, and radiation, each playing a crucial role in the thermodynamics of buildings. These processes influence design decisions, from material selection to installation strategies, ultimately shaping a building's overall performance. At its core, heat transfer is driven by the second law of thermodynamics, which states that heat naturally flows from areas of higher temperature to those of lower temperature, until thermal equilibrium is reached. With the basics in place, let's explore how heat moves through different mediums. Starting with conduction, the most direct and tangible form of heat transfer. Conduction is heat's journey through solid materials. When objects come into contact, thermal energy moves from the hotter object to the cooler one, molecule by molecule. The efficiency of conduction depends on the thermal conductivity of the materials involved, with more efficient conduction meaning less insulating properties. Steel and concrete, for example, are highly conductive. They allow heat to escape or enter a building quickly. Wood, on the other hand, acts as a natural insulator. To put this into perspective, a steel beam conducts heat approximately 356 times faster than a cross-laminated timber panel. In concrete, more than 13 times faster. While conduction governs heat flow within solids, convection becomes the dominant mechanism when heat moves through the air around us. Convection moves heat through fluids, typically air in buildings. As a fluid, such as air or water, is heated, it becomes less dense and rises, while cooler water or air sinks to take its place, thus creating a continuous flow. This cycle can be natural, like warm air drafting upwards in a sunlit atrium, or forced, like through HVAC systems. Well-designed timber buildings take advantage of this dynamic. CNC milled joints create airtight seals that block drafts, while the hygroscopic nature of wood helps regulate humidity, keeping indoor air quality stable and fresh, without over-reliance on mechanical systems. Convection keeps the air moving, but radiation brings the heat literally across space. Radiation is the transfer of heat through electromagnetic waves. No air, surface, or direct contact required. It's how the sun's warmth reaches us across millions of kilometers of space. Every object emits radiant energy based on its temperature. Architectural materials can be chosen not only for their structure, but for how they interact with this energy. Mass timber, for instance, absorbs heat throughout the day and slowly releases it as temperatures drop. A cross-laminated timber ceiling can soak up solar warmth and gently radiate it back into the room after sunset, maintaining a steady indoor climate with less mechanical intervention. The way a building handles radiation hinges on material properties and spatial design. Orienting windows to capture or deflect solar energy and using surfaces with high absorptivity or reflectivity can significantly enhance thermal performance. Smart radiation control, therefore, isn't just passive, it's strategic. A deep understanding of conduction, convection, and radiation enables architects and engineers to design buildings that are not only more energy efficient, but also more comfortable and resilient. By minimizing conductive heat loss through effective insulation, enhancing convective airflow with smart ventilation strategies, and optimizing radiative heat gain through orientation and material choice, designers can harness the physics of heat and use it to their advantage. Incorporating materials with high thermal mass, such as concrete or bricks, adds another layer of efficiency. These materials absorb heat during the day and release it gradually during the night, helping to stabilize indoor temperatures and reduce reliance on mechanical systems. The result? Buildings that work with nature, not against it.
Stay informed, stay inspired. TimberTalk.